Hello everyone and welcome to another video. In this video I'm going to talk about binary numbers. A binary number is a series of one or more binary digits, also known as bits. And a binary digit can be a 0 or a 1. Bits. As specified earlier, this is short for binary digits, can either be a 0 or a 1. Computers store data using binary numbers. So anything you save on a computer, whether it's a video, an image, a document, etc., will be stored using binary numbers. Now, if we compare this to the numerical system we use in everyday life, which is the decimal system, it will bring some clarity. So, the decimal system has 10 different digits, and that's 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. So these are the 10 different digits in the decimal numerical system. The reason why there isn't a digit or symbol for every number is because it will be very inefficient to have to memorize all of those digits and numbers. So to represent a number, to remember all of those digits and symbols or symbols. So for numbers above 9 in the decimal system, we use positional notation. So once we've gone up to 9, let's say we've gone 0, 1, 2, 3, 4, 5, 6, 7, 8, and we've reached 9. Now, if we want to go above 9, we can no longer use a single digit because 9 is the highest digit in the decimal numerical system. So what we do is we replace the 9 with a 0 and we add a 1 to the column to its left, right? And this is known as 10. This number is known as 10. What it is a 1 in the tens column and a 0 in the ones column, or also known as the units column. Okay, so that's where the positional part comes in. So let's say we've got the number 1063. Okay. This column is the ones column. This column is the tens column. This column is the hundreds column. And this column is the thousands column. Each column is 10 times greater than the column to its right. So the thousands column is 10 times greater than the hundreds column. The hundreds column is 10 times greater than the tens column, and the tens column is 10 times greater than the ones column. Okay, so these are also all powers of 10. So this column is 10 to the power of 0. This column is 10 to the power of 2. This column is 10 to the power of 1. This column is 10 to the power of 2, and this column is 10 to the power of 3. So let's change this number. Let's use a different number. So let's say 3,731. I'm spacing the digits out so I've got room to write underneath them. Okay, so we know that this is the ones column. This is the tens column, this is the 100s column, and this is the 1000s column. The reason why they are named as such, the hundreds, the thousands, hundreds, tens, ones, is because the number here in this column means that there's this many instances of 1. The number in this column means that there's this many instances of tens. And the same for these with hundreds and thousands. So this number 1 means there's 1 instance of 1. This number 3 means there's 3 instances of 10. Number 7 means there's 7 instances of 100. And number 3 means there's 3 instances of 1000. And if we were to write it using powers, we'd say powers of 10. Would say this is 1 times 10 to the power of 0. This is 3 times 10 to the power of 1. This is 7 times 10 to the power of 2. And this is 3 times 10 to the power of 3. Okay, so this is decimal. Now, binary uses the same principles, but there's only 2 different digits. So if I get rid of this number, these now here, and binary. Now, as I said, there's only 2 different digits. So once we get to 1, so we've got 0 and then we've got 1, we cannot go above 1 in binary using the single digits. So as we did with decimal, we go back to 0. And then we add a 1 to the column to the left. Okay, so this is the 1's column, and this is the 2's column. Yeah, because there's only 2 different digits, it doubles each time. So the column, each column is 2 times the column to its right. Okay, because there's only 2 different digits. So if I was to write, let's say 1, 0, 0, 1. Now, we know this is the 1's column, this is the 2's column, this is the 4's column, and this is the 8's column because it doubles each time. So this column 8 is double the column to its right, so it's 2 times 4. Yeah, this column here, the 4's column, is double the column to its right, so that's 2 times 2. And this column here, the 2's column, is double the column to its right, which is 2 times 1. And each column is also a power of 2. So this column is 2 to the power of 0. This is 2 to the power of 1. This is 2 to the power of 2. And this is 2 to the power of 3. Okay. Because it's base 2, so each column is a power of 2. Okay. So if we were to convert a number from decimal, base 10, to binary, base 2, there'll be more digits in the binary representation of that number because each column, the digit in each column has a lower value, apart from 1. So if you had 1 decimal and 1 in binary, they have the same value. But as soon as you go above that, yeah, then you need more digits to represent it. So as soon as you go to 2 in decimal, then you cannot represent the same number in binary using 2 because there is no digit 2 in binary. Yeah, so what we'd have to do here is go back to 0 to increase, when you get to 1 in binary, to increase it by 1 more, yeah, you have to go back to 0 in the 1's column and put a 1 in the 2's column. Yeah, so these numbers are equivalent. Okay, so it takes more digits to represent the same number. To represent a number in binary, yeah, it takes more digits than that to represent that same number in decimal. So we have, let's take a different number. Let's say 162. Okay, so we got 162 in decimal and we wanted to represent that same number in binary. Okay, what we'd need to have is we need to have a 1 in the 128th column, 0 in the 64th column, 1 in the 32's column, 0 in the 16s, the 8s, the 4s, the 2's column will have a 1 and the 1's column will have a 0. So these two numbers are equivalent. Okay? Because you know this is the hundreds column in decimal, and then the tens column, and then the units column. And we know this is 2 times 10 to the power of 0. This is 6 times 10 to the power of 1. And this is 1 times 10 to the power of 2. Okay. This here, binary, this is the 128's column. This is the 64's column. This is the 32's column. This is the 16's column. The 8's, 4's, 2's and 1's column. So that means this is 0 times 2 to the power of 0, 1 times 2 to the power of 1, 0 times 2 to the power of 2, 0 times 2 to the power of 3, 0 times 2 to the power of 4, 1 times 2 to the power of 5, 0 times 2 to the power of 6, and 1 times 2 to the power of 7. Okay. So if we look, we've got 162 decimal. Then if we look at the same number in binary, we got 1 in the 128's column, 0 in the 64's column, 1 in the 32's column, in the 16's, 8's, 4's column, and 1's column we've got 0 and we've got 1 in the 2's column. So that's 128 plus 32 is 160 plus 2, 162. So this number, these two numbers are the same, equivalent. So this is how you represent 162 in decimal is represented with this number in binary. And there are other numerical systems as well. It's not just these two. There's base 16, also known as hexadecimal. There's base 8, there's base 12. And they all follow the same principles. Okay, they all use positional notation. There's also, with bits, there are ways to group them to make using them easier. So there's 4 bits, which is a nibble. There's 8 bits, which is a byte, which you've probably heard of. And then you've got kilobytes, which is 1024 bytes. You've got megabytes, which is 1024 kilobytes. You've got gigabytes, which is 1024 megabytes. You've got terabytes, which is 1024 gigabytes, and so on and so forth. These are used in things such as phone storage, smartphone storage. So smartphone storage will usually be, or will be, a n gigabytes. So starting from 16 gigabytes and doubling each time up until 512 gigabytes and potentially beyond. And storage capacity on laptops and desktops will be in either gigabytes or potentially terabytes in this large amount of storage. So that's where those groupings come in handy with working with large numbers of bytes, large numbers of bits. So I say those groupings become helpful. And that is how the binary numerical system works. I hope you found this video helpful. If you did, I'd appreciate it if you could like and share the video. And to see more content like this, you should subscribe to my channel. Until next time, all the best.